For u substitution, which is section 5.5, example number 7 is solved by trying to get everything in terms of u. So the first thing we're going to do with example 7 is set a box up off the right-hand side or the left, but have that box area where you can do all your small work and then apply it to the problem. So we start by allowing the baby, which is under the radical, to be our u value, u meaning u substitution. And then we isolate x, so we move the 1 over, and this reads u plus 1 equals x. Now at that point, I can change my x, which is right here, into u plus 1. And I can change x minus 1, which was my baby, into u, which I did right here. The only thing left to do is change dx into a form of du. To do that, go back to either this equation or to the isolated x equation and take the derivative of both sides with respect to x. When you do that, you're going to end up with d dx of u for this side and just 1 on the other side. Now at this point, you want to get dx isolated. And even though d dx is truly not a fraction, we can allow it to be treated as a fraction. So we move the dx over to the other side, and we'll get du equals 1 dx. Now I can replace the dx with du, so dx becomes du, and then I can treat this like I would any other integral problem. When you're doing the integral, you'll discover that this part here has a derivative that is not present in this, and this part here has a derivative that is not present in this. Therefore, we cannot use the reverse chain rule or the general power rule. Instead, we're going to have to distribute u to the 1/2 over both these terms, which give us these two terms, and then we take the integral of each term. When I take the integral of each term, don't forget the du, and then I'll end up with 5/2. 3/2 plus 1 is 5/2. 1/2 plus 1 is 3/2. Then I simplify it into this expression, and then I go back up to what u is. It's x minus 1. Plug that x minus 1 in here, and don't forget your plus c. You're done with number 7. For example number 8, we're going to have to let u be the baby. The baby is almost always going to be under a radical symbol, so u is equal to 2x plus 3. Then take the derivative of u equals 2x plus 3, and you'll get d dx of u, and then d dx of this gives you just 2. Move the dx over. You now have du equals 2 dx. Isolate dx because we want to replace it with something in terms of du. And so we move the 2 over, and now I know what dx is. It's 1/2 du. So we replace dx with 1/2 of du. So the baby, being 2x plus 3, which is really u, can be differentiated. And when I take the derivative of both sides with respect to x, then this side becomes du dx, and this side becomes 2. Again, treat du dx as a fraction, even though it's not a fraction. Move the 2x or the dx over to this side. I have du equals 2 dx. But go back to your original equation. I don't have a 2 dx here. All I want is dx replaced. So I move my 2 here over to the other side. This is dx. So I then replace dx with this, and that's what's going to go right here. Then I go back to what u is, and I isolate x. And if I work through the problem and isolate x, I get 1/2 u minus 3/2. That is going to replace the x right there. That's why I have an arrow drawn down to there. I replace the baby with just u. So now I have 2 times the x value, which came from here, minus 1, because I have a minus 1 there. And then I have u to the 1/2, which is basically u's square root. I replace dx with 1/2 du for my work up here. And then I look at it and say, let's clean it up. 2 times 1/2 is just u. 2 times negative 3/2 is just 3. 3 minus negative 3 minus 1 is going to be a negative 4. And then I divide u to the 1/2 into those terms. And when I do, it's going to clean up really nicely, because I'm going to have this 1/2 here, And I'm going to have to say u to the plum half with this as my numerator. And I'll divide this into this, this into this. These two combined, by the way, are actually that value there. So I can divide this into the first term, this into the second term, and then I can have two separate integrals. Integrate each of them, add c, plug back in what the u value was, plus c, and then you get your answer. But only put your answer in this form if you're looking for domain restrictions. Now another way to work through from this step to this step is to look at the 2 right here, multiply by 1/2, and the 2 and the 1/2 both drop out. Then I'm left with 1/2 u minus 3/2 minus 1, which is really this expression right here. So that might be a faster way to see how we got